Greetings and welcome to Lesson 1.5, Property of Real Numbers. In this video, we're going to discuss properties that allow us to manipulate real numbers in such a way that we can start solving algebraic equations. Let's start with the most common properties that we are going to use, and they are the commutative property of addition and commutative property of multiplication. So what commute means is to exchange, meaning if we change the order of addition and order of multiplication, it won't matter. But they're separate, so I want to be very clear. The commutative property of addition is if A and B are real numbers, then A plus B will equal B plus A. Likewise, with the commutative property of multiplication, the order doesn't matter in which I multiply it by. If A and B are real numbers, then A times B will equal B times A. So what are some examples that you can come up with? Well, something very simple for addition would be 1 plus 2 is the same thing as 2 plus 1. Those both equal 3. It doesn't matter which order you do it in, it's the same thing, it's 3. Likewise, if we say 2 times 3 or 3 times 6, either way, 3 times 2 is 6 and 2 times 3 is 6, so the order doesn't matter. And I've written some examples down here. 5 plus x plus 3 is the same thing as x plus 5 plus 3. It's the same thing as x plus 3 plus 5. Ultimately, our result is going to be x plus 8. And then for multiplication, 2 times y will be the same thing as y times 2. Now, if those are the only values that we have, we don't necessarily would write it as y plus 2. We would write it as 2y. Another property that both addition and multiplication have is the associative property. So the associative property of addition, the associative property of multiplication. Now, what does associative mean? If you think about it, if you belong to association, you belong to a group. And what this means is that the changing of the group doesn't change the result. So for addition, if A, B, and C are real numbers, then A plus the quantity B plus C is going to be the same thing as the quantity A plus B, then plus C. And if you remember, with order of operations, this really does matter because the parentheses come first. Let's pretend that A, B, and C are real numbers, and I'm going to say that A is 1, B is 2, and C is 3. And if I do the math around that, 1 plus 2 in parentheses plus 3, those should equal one another. So 2 plus 3 is 5. I'm working on the left-hand side. Plus 1 is 6. Well, 1 plus 3 is 3. 3 plus 3 is 6. So, of course, 6 equals 6. Now, with the associative property of multiplication, changing the grouping, again, does not change the result. If A, B, and C are real numbers, then A times the quantity B times C will be the same thing as the quantity A times B equals C. Again, if I use the same numbers 1, 2, and 3, if B times C, that would be 2 times 3, is 6, and then I multiply it by 1, the answer is still 6. Now if I take 1 times 2 first, and that's a 2, 2 times 3 is still going to be 6. But let me scroll down and show you a couple more examples. Sorry, my wiggliness there. 4 plus, in parentheses, 5 plus x is going to be the same thing as 4 plus 5 plus x. Either way, it's going to be 9 plus x. And then likewise, 5 times 2x will be the same thing as 5 times 2 times x, which will be 10x. This is going to come in really handy in just a short time when we start really working with these properties to solve linear equations, I guess I'll call them. Just equations in general. We can start using these rules to start solving for our unknown. So I put up a few examples here, and if you go ahead and try these, write them out. I have the solution down on here, but go ahead and try them out yourself. So 7 plus A plus 6 plus 5. And then another one is 4 plus B plus 6. 3 plus B plus 7 plus 1. Okay, so try those out. If you use associative property to group the numbers with the numbers and the letters with the letters, it will help you out quite a bit. The next property I want to discuss is the distributive property. Its multiplication distributes over addition. But I don't want you to get caught up in the word addition, because if you remember, subtraction we can write as addition. So multiplication really distributes over addition and subtraction. We just don't always rewrite subtraction as addition. So it does go over both of those operations, addition and subtraction. So what is it that I just said? The pure definition is if A, B, and C are real numbers, then A times the quantity B plus C will equal A times B plus A times C. This A distributes across to B and as well to C. So it goes to both of those values. There's a very interesting way of looking at this. I think it's interesting. So I'm going to go through the full explanation. So let me scroll up just so you can see my rectangles better. And what's going to happen here is, if you think about this, I have a big rectangle, and I want to find the area of this rectangle. The area of a rectangle, its formula is length times width. Well, I know what the width is. The width is 5 inches, but my length is 3 plus 4 inches. So if I rewrite this, area equals length times width, but remember, multiplication is commutative, so I can switch it around, so that's really length times width. My length is 5, and my width is 3 plus 4. Well, 3 plus 4 is 7, so 5 times 7 is 35 inches squared. But that's one way of looking at this. The second way of looking at it is, what if I just took rectangle number 1 and rectangle number 2, found out those two areas for each of those rectangles, and then added it up together? I would have the big yellow rectangles area, wouldn't I? I mean, I add the first and I add the second, I get the whole entire thing. So let's figure this out. The area of rectangle 1 is going to be 3 times 5 inches. In other words, 15 inches squared. The area of rectangle 2 is 4 times 5 inches, which is 20 inches squared. Well, the area of my large rectangle is going to be my first area plus my second area. 15 plus 20 is 35. My answer is exactly the same. That's the distributive property of multiplication. I have a couple more examples for you. Just move myself out of the way there. 2 times a quantity x plus 3. Using my distributive property, it's going to be 2x plus 2 times 3. The only extra math I can do there is the 2 times 3. So my solution is 2x plus 6. My second problem, 5 times 2x plus 4y. So 5 times the quantity, 2x plus 4y. Remember, I'm going to distribute the 5 to the 2x as well as the 4y. So when I distribute, it becomes 5x, 5 times 2x, 5 times 4y, giving me 10x plus 20y. Now, I've given you a few problems to try on your own. And yes, I know a couple of them have fractions, but fractions we know how to work with, so no harm, no foul there. And if you'd like the solutions, let me know, throw me an email, and I'll give you the solutions to these. Now, there's some very special numbers, and they have properties in themselves. We have an additive identity property, So there exists a unique number, 0, such that a plus 0 will equal a, and 0 plus a equals a. So adding this very special number to anything doesn't change it, and that unique number is 0. We have the multiplicative identity property. There exists a unique number, 1, that is our unique number, such that if we multiply any number by it, it doesn't change. So a times 1 is a, and 1 times a is a. The additive inverse property means that there exists a unique number such that when you add it to a real number, a, the sum yields 0. So what does that all mean? Well, what that means is if I add this number, a, and I add another number, that when I add them up, it will be 0. The only way to do that is with the opposite of a. So a plus the opposite of a will get me 0. So let's pretend a is 2. What's the opposite of 2? Negative 2. So 2 plus negative 2 will give me 0. Okay, let me say that again. Let me choose any other number. Negative 3. What's the opposite of negative 3? Positive 3. So if I add those two together, negative 3 plus positive 3 will give me 0. That is the additive inverse property. The multiplicative inverse property is very similar to the definition of a reciprocal. In fact, it's that very special number that if we multiply it to, it is its reciprocal, right? So for every real number a except 0, there exists a unique real number, 1 over a, such that when we multiply it together, it's going to be 1. So a times 1 will equal a, and then you have to assume that there's a 1 underneath there. Sorry about that. Here's an implied 1 there, so a times 1 is a, and 1 times a is a, but a over a is 1. So the multiplicative inverse property is similar to the reciprocal. So you should be familiar, and go back in the video, but you should be able to name any of these properties down here. For example, 3 plus 0 equals 3. Well, that's going to be the additive identity property because 0 is the additive identity. We add 0, but it doesn't change anything in the end. 2 plus negative 2 equals 0. That's going to be the additive inverse property. 1/2 times 2. If I did that, 1/2 times 2, that's going to be 1. That's the multiplicative inverse property. 4 times 1 equals 4. That's going to be the multiplicative identity property. It doesn't change it. That's its identity still. Before the multiplication, it's 4. After the multiplication, it's 4. Think of it as that's its identity. So that's it for this video. If you have any questions, please contact me. Otherwise, be seeing you.